simplify the imaginary expression, rationalize the denominator. So before we go any further, here we can apply the identity property of multiplication. For example, if I multiply everything by 1, still I'm going to get the 7 over 4i. But on the other hand, I want here to rationalize the denominator. Here I have I. If I multiply by I denominator and numerator, so by I this way, and I already know this is going to be equal to 1. So it gives me an opportunity now to use 7 over 4i time I want to rationalize I over I. So that's why we can have a right to use this way to multiply by I over I, because we are using here identity property of multiplication. And now if I'm multiplying here this fraction, this expression in the form of the fraction, is going to be 7i divided by 4i squared, because 4i times I is a 4i squared. But according to the rules of according to the definition of the complex numbers, we already know the I square here, this is I square, and this I square is equal to minus 1. It's equal to minus 1. And now minus 1 times 4 is minus 4. So the result here is going to be 7i divided by negative 4. Or to make a little bit better this case, so to write in a better form, we can write this as 7i negative 7 over 4. Negative 7i over 4. And so this is the final answer on the A. So now we are going B here. And according to the rules, how we can rationalize this expression here, 6 plus 8i. So we are looking to find a complex conjugate. The complex conjugate of 6 plus 8i, we have a 6 minus 8i. So the conjugate complex number of a number is a number that is the same real number and imaginary part, but with the exception the difference is in the sign. Here is positive, here is negative. And I know when I'm working with this, when we are working with this the conjugate, when we are multiplying up and down, we now we are going to apply the difference square formula. We know the difference square formula we already know from the previous lesson. A square minus b square is equal with this is a equal, let me write equal, with a minus b times a plus b. A minus b times a plus b. And a plus b. And what do we know here? We know this is a and this is b. We have the same scenario, but when we are multiplying, is going to be in the denominator. So here I'm using just the denominator. Is going to be a square minus b square. So it's going to be 6 square. So 6 square minus 8i square. So we are taking a little shortcut. We don't have to multiply, or if we don't feel comfortable, we can distribute, we can multiply those two binomials. And now on the numerator, we multiply 5i times 6 is a 30i. So this is equal to 30i. And 5i times negative 8i, the sign is a negative. 5 times 8 is a 40. And I times I is I square. I square. And then we can simplify a little bit here. So 6 square is 36. 36 is a negative, and 8 square is 64. Let me write 64. And I is I square. And I here is I square. So that's what we have. And on the upper part, we have a 30. is a negative. But now this I square here is equal to the minus 1. So let me write this I square is minus 1 according to the definition of complex numbers. And because it's a minus 1, now minus 1 times minus 40 is plus 40. Just let me write here I minus 40 is a plus 40, because negative 1 times negative 40 is positive 40. But now here I will write this, I will write in the standard form on the top here. I will write in the form of a plus bi. So in the standard form. And if I write in the standard form, I can write this as a 40 plus 30i. And down here, I know this is equal with minus 1. I square is minus 1. And now we have a 36. We have a 36. And negative is a positive, plus 64. And now we already see this here. Let me write. And this is an I forgot to write. Let me rewrite here everything. 40 plus 30i divided by 100. 30i divided by 100. That's what we have. And in the end, we can simplify a little bit further. And 40 divided by 100 is 0.4. Here is a plus. And 30 divided by 100 is 0.3i. 0.3i. Just let me say, here we wrote in the standard form, because standard form of the complex numbers is a plus bi.